friends, in the playlist of Discovering Statistics Using Jamovi. Today we will discuss one-way ANOVA. Assumption of one-way ANOVA, how to check these assumptions, how to make decisions, how to report the findings, and what is Posthoc ANOVA, and how to perform the Posthoc ANOVA. Let's start. One-way ANOVA. The one-way analysis of variance means ANOVA. Analysis of variance means ANOVA is used to determine whether there are any statistically significant differences between means of two or more independent groups. Friends, ANOVA tells us about the difference of means. But you can check the name of ANOVA when we check the abbreviation ANOVA. It is analysis of variance, but it tells us about analysis of means. But it is true. When I will show you the process of ANOVA, all the process goes through by analyzing variance. So name is the true. It tells us about analysis of mean, result is about analysis of mean, but the process is going through variance, so the name is correct, analysis of variance. The one-way analysis of variance is an extension of independent t-test. When independent t-test exists and it is the extension of independent t-test, can we perform multiple t-tests? Can I conduct the multiple t-tests instead of ANOVA? Suppose I would like to check is there any statistical significance difference between mean of three brands, brand 1, brand 2 and brand 3. Suppose this is the statement. I would like to check the difference between three brands. In this case, if I apply t-test, then I have to perform three tests. Test 1 between brand 1 and brand 2, test 2 brand 2 and brand 3, test 3 between brand 1 and brand 3. Friends, I have to use the software. What is the problem if I conduct multiple t-tests instead of ANOVA? Yes, there is a problem. Every time I conduct a t-test, there is a chance that I will make a type 1 error. This error is usually 5% as we take level of significance in social sciences. What is the meaning of type 1 error? If I conduct a test 100 times, there is 5% chances. 5 chances out of 100 means null hypothesis is true and by mistake I reject it. This is called type 1 error. If I perform one test, then the error rate is 0.05. Two groups, one comparison. The error rate is 0.05. If there are three groups, I have to compare three comparison. I have to perform three comparison. In that case, the error rate of type 1 error will be 0.14265. The formula of error rate is 1 minus alpha raised to power c. We have to compare three groups. In this case, the error rate will be 0.142625. But I would like to reduce my type 1 error. These are unacceptable errors. I can be more confident that any statistically significant result I find is not just running lot of tests. Friends, now you can understand what is the problem by running multiple t-tests. In this way, our error rate will be increased. So, we will use here ANOVA test. ANOVA try to maintain the error rate, type 1 error rate at 5%. Let's start with an example. A car manufacturer certainly planning to conduct the test to know the performance of three different brands of 12-volt battery. So he selected 5 batteries from each brand and discharged them under the controlled condition. Assuming the lifetime of battery are normally distributed, I am taking assumption here, normally distributed. Friends, I am showing here you a manual method. And I am performing this test at 5% significance level, or we can say 95% confidence level. This is a statement, brand 1, brand 2, brand 3. We have 5 items from each brand, brand 1, brand 2, brand 3. Let's check the calculations. For this calculation, first step, calculate mean of each sample. To check the mean of each sample, 16 plus 14 plus 13 plus 16 plus 12, total is 71. Divided by 5, we will get 14.2. As this, I will calculate mean for brand 2 and mean for brand 3. Next step, calculate mean of means. Mean of means, divide mean of means means grand mean. 14.2 plus 17 plus 23.2. In this way, we will get grand mean. Grand mean is here 18.13. Next step, work out SS between samples. Formula for SS between sample, N1 into X1 bar minus grand mean raised to power 2. Let's check in our case. Item in first sample, 5 into 14.2, mean of first sample 14.2 minus grand mean 18.13 raised to power 2. I will repeat this for second sample and third sample also, then take the total. Total is 212.133. Work out SS within samples. Within sample, sigma x1I minus x bar 1 means start from first sample or first item of first sample. Let's check. 16 minus x bar 1, 14.2 raised to power 2. We have to raise to power, take the raised to power 2 plus second item 14 minus 14.2. In this case, we have to take deviation with mean of first sample with each item of first group, and repeat this process for brand 2 and brand 3. In this way, I will get the total 95.6. Next step, SS for total variance, sigma xij means I have to take total of, take first item from first sample, second, all the items from first sample, all the item from second sample and all the item from third sample, and subtract grand mean from each these. Now, how to check? SS total, 16 minus 18.13 means we have to deduct grand mean, and we have to repeat this process for all the items. In this way, I will get the total variance for my table. In this way, we have calculated SS between, SS within, SS total. Note down these values: 212.133, 95.6, 307.733. In this way, I will put this value in my layout. 212.133, put this value here, 95.6, and this total 307.73. Degree of freedom, we have already discussed. Degree of freedom for between sample is 2, within sample is equal to 12, and total 414. Now, how to calculate mean square? Only simple way to check the mean square. 212.3 divided by 2, this is the mean square, 106.6, and 95.6 divided by 12, 7.96. When I divide mean square between divided by mean square within, I will get the F ratio. On the basis of this F ratio, we will take the decision. This is manual method. For this, we have to check table value. How to check the table value? These are null hypothesis and alternate hypothesis. Mu1 is equal to mu2 and this mu3. And alternative hypothesis is at least one of the brand mean life is different from the life of others. This is the table of, this is F table. To check the F table, we will use the degree of freedom. We will check degree of freedom 2 and 12. Add the degree of freedom 2 and 12. I find the value here 3.89. The calculated value is 3.89 with the degree of freedom 2 and 12, and level of significance is 0.05. Our calculated value 13.32 is greater than 0.389 if our calculated value is more than table value. In this case, our null hypothesis is rejected. In this case, we have rejected null hypothesis, means there is significant difference between three brands. What is F ratio? It is the ratio how good the model is compared to the how bad it is error. The sample, the source of variation between sample has been explained as 106.6. The source of variation which have not been explained by sample, the variation within samples are, we can say error or we can say residual. This is 7.6. This is the ratio of F ratio is between sample and within sample. Mean square between sample and mean square within sample. In this way, we can perform the test manually. Let's start working example with software. An economist wishes to compare mobile bill in four major cities: Delhi, Mumbai, Chennai, Calcutta. In Delhi, four cities are here. We would like to check mean difference of mobile bill between four cities. Among four cities, she obtained random sample from 25 respondents from each cities. This is the data entry format for Jamovi. In first column, respondent ID, we will note down serial number. Second column, city. There are four cities: Delhi, Mumbai, Chennai, Kolkata. We have to give code: Delhi 1, Mumbai 2, Chennai 3, Calcutta 4. And mobile bill is equal to in column 3, and this is the actual data. This is on ratio scale and this is on nominal scale. Hypothesis in this case, the null and alternative hypotheses are mu1 is equal to mu2 and is equal to mu3 is equal to mu4, and alternative hypothesis, not all mu are equal. In other words, the null hypothesis that at all of the group's population means are equal. The alternative hypothesis, there are at least two population means that are not equal to one another. How can I understand this? I have a table for it. Means what is the meaning of this alternative hypothesis? The alternative hypothesis means if any of these groups, means these five groups are same but this group is different. These five groups are same but this group is different. In this case, if any of these comparisons, there are 6 comparison. ANOVA will do 6 comparison for us, but it will not tell us which group is different. It will only tell us whole result in totality, means null hypothesis accepted or rejected. Assumption testing. Dependent variable should be measured at interval or ratio scale, and they are continuous. Yes, in our case, in our working example, mobile bill is on ratio scale. Independent variables should consist of 2 or more categorical independent groups. Yes, in our case, we have 4 cities. We are going to compare 4 independent cities and their mobile bills. Independence of observation, which means there is no relationship between observation. Yes, in our case, we have need not to check. This is the part of our research design. There is no relationship between the respondents, mobile bills of respondent of in any city. There should be no significant outliers in each category, and significant outliers will be checked by box plot. In our case, we will check these significant outliers for each city. Each category means each city. In our case, each city. We have to check the outlier, not as a whole. We have to check for each category separately. Dependent variable should be approximately normally distributed for each category. Friends, keep it noted down. When we have to check the outlier, we have to check the normality. We have to check the normality for each group, each category separately. To check the normality, here we will use Ttest or Shapiro-Wilk test. It depends on the size of sample. If size of sample is less than 50, we can use Shapiro. If it is more than 50, you can use Ttest. Last assumption, there needs to be homogeneity of variance between different groups. Friends, we have 4 groups. We have to check there should be homogeneity of variance between the groups. To check the homogeneity variance, we will use lemon test for homogeneity of variances. As I already discussed, assumption 1, 2, 3 are the parts of our research design. We don't need to check, and it cannot be checked with any software. Assumption 4, 5, 6, outlier, normality and homogeneity variance should be checked. Let's start to check these assumptions. I will use here the software Jamovi, and my file name is one-way ANOVA 4cities.omv. This is my Jamovi software. I have opened the file. Let's check our file first. This is ID. This is city. Double click on the cell city. We can check here. We have the data for 4 cities: Delhi, Mumbai, Chennai, Kolkata. When I click on wheel of mobile, it is on continuous scale, means interval or ratio. Jamovi takes interval and ratio as continuous level. Let's start. We will start with descriptive. To check the descriptive, click on analysis. In analysis exploration, click on descriptives. To check the descriptive, I would like to check the descriptive. Below mobile is my mean variable on ratio scale, and CT split by, shifted by, split by. I would like to check here mean. I don't need median, and I would like to check standard deviation. I don't require maximum, and I need normality. I will check the box normality, and in plots I will check box plot. Let's check our output in output region. This is my output. Descriptive. Descriptive tells me N, Delhi, Mumbai, Chennai, Calcutta. There are 25 respondents from each city. No missing value. Mean Delhi 497.28, Mumbai 515.84, Chennai 531.20, Calcutta 553.56. ANOVA tells me, is there any significant difference between means of these values? The standard deviation. Standard deviation 56.634 Delhi, for Mumbai 56.53, from Chennai, for Chennai 63.98, for Calcutta 68.78. And this is the value of Shapiro-Wilk test. Because our sample size is less than 50, I can check the value of Shapiro-Wilk for my normality. If these values are greater than 0.05, means assumption of normality is met. Means I can check the values are 0.785, 0.822, 0.949, 0.698. Yes, our assumption of normality is fulfilled. Let's check about box plot and take decision about outliers. Yes, we get clean box plot in this case. There are no weak outliers or no strong outliers. If I get weak or strong outlier, you can see here dots on upper side or lower side from any side. In this way, I have checked my two assumptions, normality and outliers. Let's come to our slides and discuss in detail. This is the descriptive N missing mean standard deviation. Friends, I have demonstrated how to calculate with Jamovi. And this is the box plot city wise. Again, I am focusing on this point, making stress. You have to calculate box plot separately for each city. Now, to take the decision about normality, we have already discussed. If this value is greater than 0.05, normality is assumed. Yes, now we can proceed further. By the way, if any category value is less than 0.05, don't worry. According to Andy Field, ANOVA test is so robust, you can go ahead. Now, our last assumption, homogeneity variances. Levin's test for equality variances. Test that the population variances are equal for or group samples are drawn from the population with same variance. What is variance? Variance is square of standard deviation. In this case, our null hypothesis will be variance of group 1 is equal to variance of group 2 is equal to variance of group 3 and is equal to variance of group 4. Alternate hypothesis will be not all variances are equal in the population. Now let's come to Jamovi, how to check the assumption of homogeneity of variances. For this, in analysis, in ANOVA, there are two options, one way ANOVA and there is ANOVA. I am using this ANOVA because there are more options than more functions, more function in this ANOVA comparison to this. Click on this ANOVA. Now shift the variable, below mobile dependent variable, city fixed factors. We will discuss effect size later, models we will later, and first of all we will check assumptions check. In assumptions check there is a box, homogeneity test. Click on this homogeneity test, and in this homogeneity test you can check here homogeneity variance Leibniz test, p value 0.560 and f value degree of freedom. If this value is p value, software generated p value is greater than 0.05, means you can see our assumption of homogeneity variance is met, means we can accept our null hypothesis that there is no difference between variances of four groups. Now come to the mean output. This is our mean output, ANOVA. Between cities, within cities, degree of freedom, mean square, f value, p value. Let's come to our slides and we will discuss in detail. Yes, this is our homogeneity variance output compared with 0.05. It should be greater than 0.05. Yes, our assumption of homogeneity variance is assumed. If homogeneity variance is not assumed, if assumed, assumption met, yes, you can go for ANOVA. If not met, you can choose the option Kruskal-Wallis test, non-parametric test. Decision rule. Compare the calculated value of test statistics with table value. If calculated test value, in our case f value is greater than table value, then null hypothesis rejected. Second criteria, compare p value with alpha. Alpha means level of significance. If p value is less than or equal to alpha, null hypothesis will be rejected. Friends, you can use any criteria, any one of these, you will get same results. This is our output. This is sum of square between samples and this is within samples. Degree of freedom, I can show you degree of freedom. We have four groups. 4 minus 1 is equal to 3 and this is within samples n minus k, 100 minus 4, 96. This is our f ratio and we will compare f ratio with critical value for f. Degree of freedom 3 and 96. If you check in the table, this value is, you will get this value 2.69. If calculated value is greater than this critical value, null hypothesis will be rejected. And if we use p value, compare this p value with level of significance or alpha. Our alpha is in this case, level of significance in this case is 0.05. If this value is low, we will reject our null hypothesis. On the both criteria, we come to the conclusion the null hypothesis will be rejected. Means there is significant difference between across the cities. At the level of significance 0.05. Putting it all together, these are my main four output. This is homogeneity variance, this is ANOVA table, this is descriptive, and this is Shapiro-Wilk test. How should I report my findings? A one-way ANOVA was conducted to determine if the bill of mobile was different for these four cities. Respondents were selected for four cities, Delhi, Mumbai, Chennai, Calcutta. We have taken 25 respondents from each city. There were no outliers. I have shown you. We have made the box plot. We have made the box plot and we have checked already. There were no outliers. Data was normally distributed as assessed by Shapiro-Wilk test. Shapiro-Wilk test was greater than 0.05 in each case, and there was homogeneity variance as assessed by the Lehman test. Our 11 test p value is greater than 0.05. P value is in our case 0.506. We will report here. And finally, data is presented as mean plus minus standard deviation. Mean 497.28, standard deviation 56.63. I will report here for Delhi, for Mumbai, for Chennai and for Calcutta. In order that, but the differences between expenditure on mobile bill in four cities was statistically significant, as we have discussed already. F, we will here mention degree of freedom 3 and 96, and our F value is 3.73 and P value is 0.1014. In this way, we can report our finding. If there is difference exists, but ANOVA does not tell us effect size, magnitude of difference. For this, we have to calculate effect size in ANOVA. How to calculate effect size? This is eta square. Formula for eta square is SSB, sum of square between and sum of square total. Let's calculate the effect size using Jamovi. In our Jamovi file, there is a option effect size, eta square, partial eta square and omega square. You can check, just I click there. Jamovi calculated these values for us. I am copying down these values, and let's come to our slides and discuss in detail about these values. This is eta square. This is our mean output. How to calculate eta square? Eta square and partial eta square for one-way analysis of variance, they are identical to each other. No need to calculate separately. And usefully, there is also an option in Jamovi to specify omega square. This is omega square, and which is less biased alongside eta square. We can simultaneously calculate eta square, partial eta square and omega square. Now here we have to calculate SSB, SS total. SSB has been given, we have to calculate SS total. Simply just add these two values and we will get this the total of this value. What is the eta square? Divide between SS between 42,632.35 divided by this value. In this way, I will get the eta square same as it. And this is the formula for omega square. If value of eta square, if it is 0, means there is no relationship or no difference between at all between the two, whereas eta square is 1, means that the relationship is perfect and the eta square value is very closely related to r square. Friends, in this way we can say our relationship is not very much strong, or we can say difference exists, but this difference is not equal to 0 and not equal to 1. It is the relationship little difference. Difference exists, but the magnitude difference is very small. If difference exists, but in which pair? Till now, we get the conclusion. Difference exists, but till now we did not come to the conclusion. Difference exists, but in which pair? Difference exists in Delhi or Mumbai, Mumbai or Chennai, Chennai or Calcutta, or Delhi or Calcutta, or Chennai or Delhi. In this way, we have to perform post hoc. What is the meaning of post hoc? Post hoc means after this. After this means if difference exists, we would like to check the difference between in which pair. Between which pair? Delhi or Mumbai, Mumbai or Chennai, Chennai or Calcutta. Before we get to these comparisons, you need to learn about the experiment wise rate. If I perform so many tests simultaneously, means 6 or 7 groups, in this way, my error rate will be increased. Post hoc test perform two vital tasks. Yes, they tell you which group means are statistically different from other group means. Crucially, they also control the experiment wise or family wise error rate. If I perform this test separately, my error rate will be increased. If I use the post hoc, it will control the error rate. What is the experiment wise error rate? For every hypothesis test you perform, there is a type 1 error which is your significance level, means alpha. In other words, we can say there is a chance that you will reject a null hypothesis that is actually true, means false positive. By mistake, you are rejecting it. When you perform only one test, the type 1 error rate is 5%. But if I conduct more and more tests, my error rate will be increased. Your chance of false positive will be increased. If you perform enough tests, you are virtually guaranteed to get a false positive. The error rate of the family of tests is always higher than the individual test. If I perform 6 or 7 tests, my error rate will be increased. How to control this error rate? In this way, any possibility will be there. If I would like to make 6 comparison, my error rate will be increased. If I perform this test separately, this test separately, this test separately, so I will not perform this test separately. I will use here post-hoc. The experiment-wise error rate quickly becomes problematic. In my case, there are 4 samples. In this case, I have to make 6 comparisons. In the case, if I perform 6 comparisons, my error rate will be 0.264902. This is the formula to calculate error rate. So I will not perform 6 comparisons separately. Here I will perform, to control the error rate, I will perform post-hoc test. The solution is to this problem is to introduce an adjustment to the p-value, which aims to control the total error across the family of tests. An adjustment of this form, which is usually but not always applied because one is doing post-hoc analysis, is often referred to as correction or multiple comparison, though it is sometimes referred to as simultaneously inference. Correction post-hoc. Let's check in Jamovi. There are some correction. You can check with no correction, Ttest, Sheffe, Bonferroni, Home. Let's check how to perform the post-hoc test in ANOVA using Jamovi. In Analysis tab, there is the option ANOVA. Click on ANOVA. There are 2 options, one-way ANOVA and ANOVA. I will show you by using both the options. First, we will click on one-way ANOVA. Let's shift the variables. Bill of mobile, independent variable. City, in grouping variables. We have here options: variance, don't assume equal Welch test, assume equal Fisher. Because in our case variance are equal, now I can check on assume equal Fisher. Now in this case, if I show you post-hoc test, none, Games oval, unequal variance. When your variances are unequal, click the option Games oval. But in our case, variance are equal, we will select the Tucky option. By clicking on Tucky option, let's check our results in output region. Here in output region, we can check Delhi, comparison with Delhi, Mumbai, Chennai, Kolkata. Comparison of Delhi with Mumbai. Here is the T value, here is the degree of freedom, here is the P value. Friends, you may check degree of freedom is 96 because post-hoc performs all these tests in one go to control the type 1 error. This is the reason the degree of freedom is 96. Delhi with Mumbai, Delhi with Chennai, Delhi with Calcutta. We have to check only P value. P value is 0.712, 0.217, 0.019. This is less than 0.05. In the case of Delhi with Calcutta, comparison with Delhi and Calcutta, there is significant difference between the mean of bill of mobile between Delhi and Calcutta. But there is no difference, there is no significant difference between Delhi and Mumbai and Delhi and Chennai. If we compare Mumbai and Chennai, the P value is 0.815. There is no significant difference. In the case of Mumbai and Calcutta, there is no significant difference because the value is 0.142 more than 0.05. In the case of Chennai and Calcutta, p value is greater than 0.05. In this way, we can perform Tucky test when the variances are equal. Now I will show you about correction. In analysis, click on ANOVA and we will click the second option, ANOVA. Now we'll shift the variables accordingly. Below mobile, dependent variables, city, fixed factors, as we have did earlier. And in this case, we will check here Posthoc. Shift this city to this variable box, and here are some options we will discuss. Correction, no correction, Tucky correction, Sheffield correction, Bonferroni, home. There are so many corrections. Now, as we have checked the box Tucky, you can check here p value calculated basis on the Tucky's formula. You can check here comparison of Delhi and Mumbai, Delhi and Chennai, Delhi and Calcutta. We will check only the p value. P value is less than 0.05 in only one case, difference between Delhi and Calcutta. There is only significant difference between Delhi and Calcutta. There is no significant difference in other comparison, Mumbai and Chennai. The value is 0.815 and Mumbai and Calcutta 0.142, Chennai and Calcutta 0.577. In this way, we can perform Posthoc test, and we can check other correction also, Sheffield, Bonferroni, home. If you click on almost same results we get. Yes, we can check here. Let's check in output region. Yes, P Tucky, P Sheffield, P Bonferroni, P home. Almost same results. Almost same. We 0.009, 0.019, 0.010, 0.10. In this way, we can perform Posthoc test using Jamovi. Let's come to our slides, and I would like to tell you something more. There is a book, Discovering Statistics Using SPSS by Andy Field. I have taken this screenshot from 3rd edition, page number 375 and 378. Cramming same tips regarding Posthoc test given by Andy Field. After an ANOVA, you need a further analysis to find out which group differs. When you have no specific hypothesis before the experiment, use Posthoc. When you have equal sample size, and group variance are similar, use REGWQO Tucky. Friends, in SPSS, as Andy Field has shown, there are two separate boxes. Equal variance assumed, there are some options. Equal variance not assumed, there are some options. And he also told, if you want grunted control type 1 error, then use Bonferroni. We have used this option in Jamovi. If sample size are slightly different, then use Gabriel's. Here is the Gabriel. You can check here Gabriel. But if the sample sizes are very different, then use Hochberg GT2. If there is any doubt about group variances are equal, then use Games-Oval procedure. This is the Games-Oval procedure. Friends, in this video, I have discussed all the concepts regarding one-way ANOVA. What are the assumptions, manual calculation, calculation with software, how to check assumption with software, how to make decision, how to report the findings, how to perform the Posthoc test. Friends, I hope this video will be useful for you. Thank you, my friends. Let's check how to perform Posthoc test in ANOVA. In Analysis tab, click on ANOVA. There are two options, one-way ANOVA. We will use both options one by one. Click on first option, one-way ANOVA. Here, shift the variables as we require. Below mobile, dependent variable, city, grouping variable. After this, you can check. There is a block Posthoc. In Posthoc, there are 3 radio buttons. Games have unequal variance. We will click on this radio button if in our case variance are unequal, but in our case variance are equal, so I will click on Turkey equal variances. Now you can check the output in output region. Posthoc, Turkey Posthoc, bill of mobile. It tells us Delhi mean difference, and this is the p value. If the p value is less than 0.05, means there is significant difference between two cities. Delhi and Delhi, no comparison. It is itself values. Delhi and Mumbai value is 0.712. Chennai, Delhi and Chennai 0.217. Delhi and Kolkata 0.09. Yes, this value is less than 0.05. Means we can say there is significant difference between Delhi and Calcutta. And next option, Mumbai, comparison of Mumbai and Mumbai and Chennai 0.815, Mumbai and Kolkata 0.142, and Chennai and Kolkata 0.57. There is only one case when we can say there is significant difference between Delhi and there is significant difference between two cities regarding bill of mobile, Delhi and Kolkata. Now let's check second option, ANOVA, and now I will click on this ANOVA. Bill of mobile, dependent variable, city in fixed factors. After shifting it, there is option model. I will click this into model terms, and now we have the assumptions, we have the option Posthoc test. Posthoc, shift this city to next box. Now you can check, there are some options: corrections, no correction, Turkey, Shefe, Born Ferroni, home. Now it is here Turkey. After the Turkey correction, now you can check here also, there is a comparison, Delhi between Mumbai, Delhi and Chennai, Delhi and Calcutta. Here you can check P Turkey's value 0.09, Delhi and Kolkata, and there difference between Mumbai and Chennai, Mumbai and Calcutta. You can check P Turkey value. Only one value is less than 0.05. You can check other also, Shefe, Bonferroni, home, or you can click on no correction. If I click on these options, the output region in the Posthoc comparison city, this is the output P Turkey, P Shefe, and P Bonferroni and P home. All the results are almost same, only there is significant difference between Delhi and Calcutta. I would like to tell you one thing more. Let's come to slides. Discovering statistics using SPSS, because we are performing all these tests using Jamovi. Andy Field book, Discovering Statistics using SPSS, book by Andy Field, 3rd edition, page number 375 and 378. When you perform these tests with SPSS, there are two separate boxes: equal variance assumed, equal variance not assumed. Here are two options: games oval, done at C, done at T3, and there are many options: LSD, Shefe, REG, WF, Turkey B, Turkey, Duncan, and we check the takeaways from the Andy Field books, cramming same test Posthoc test. After an ANOVA, you need a further analysis to find which groups differs. When you have no specific hypothesis before the experiment, use Posthoc test, when you have equal sample size, group variance are similar, you may use R, E, G, W, Q or Tucky. In Jamovi, Tucky option is available. If you want guaranteed control over type 1 error rate, then use Born-Ferroni. We have discussed what is a type 1 error. When we perform multiple tests by using Posthoc, we can control the type 1 error, and Born-Ferroni is the best option to control the type 1 error. Other tests also control the type 1 error. If sample size are slightly different, then use Gabriel. But if the sample size are very different, these are slightly different and these are very different, Hochberg GT2. If there is any doubt that group variances are equal, you don't know about the variance are equal or not equal, you have any doubt, then use the Games-Howell procedure. Here you can see Games-Howell procedure. Friends, in this video we have discussed what is one-way ANOVA, why we should not use multi times t-test, what are the assumptions of ANOVA, how to perform ANOVA manually and with the help of software, how to check the assumption, how to interpret the results, how to report the findings, and what is Posthoc and how to perform the Posthoc ANOVA. Friends,